Quantum neuroscience, exploring the quantum nature of the brain. 1. Justifying the quantum nature of the brain. The brain, despite being a macro-material body, exhibits characteristics that align with quantum mechanics principles. Quantum neuroscience posits that the brain operates on quantum principles to explain phenomena that classical neuroscience cannot fully address. Here are several arguments justifying how the brain can be or is quantum. A. Quantum coherence and brain function. Quantum coherence is a state where particles, such as neurons, or synapses maintain a phase relationship over time and space. Brain functions, such as consciousness and thought processes, exhibit a high degree of coherence, which classical physics struggles to explain. Studies have shown that coherent brain waves, particularly gamma waves, indicate synchronized activity across different brain regions. This coherence aligns with the quantum phenomenon of entanglement, suggesting that parts of the brain communicate in a non-local, instantaneous manner. B. Quantum measurement and decision-making. The process of decision-making involves collapsing multiple possibilities into a single outcome. Akin to the quantum measurement problem, where a quantum system collapses from a superposition of states to a definite state upon observation. The brain's decision-making process reflects this quantum principle, where potential actions, or analogous to quantum states, are considered until one is actualized through conscious choice. C. Quantum tunneling in neuronal activity. Quantum tunneling, where particles pass through potential barriers, can explain how neurotransmitters traverse synaptic gaps efficiently. Classical physics would predict a slower, less efficient transmission of signals across neurons, but the observed rapid signal transmission in the brain suggests a quantum mechanical process at play. D. Consciousness and quantum non-locality. Consciousness itself may be a quantum phenomenon. The idea of quantum non-locality, where entangled particles affect each other instantaneously across distances, parallels the brain's ability to integrate information from disparate regions to form a unified conscious experience. This suggests that consciousness could arise from quantum processes within the brain's microtubules or synapses, as proposed by theories like the Auro-Multiverseom, orchestrated objective reduction, by Penrose and Harmov.